Welcome back, everyone. Today's Deep Dive is brought to you by Safety One Source.
And we're going to be talking about some crucial OSHA scaffolding regulations.
So if you're a safety pro or just someone who wants to make their workplace safer,
you are in the right place.
We're going to be pulling information directly from OSHA Standard 1926.451.
Making sure you have got the most accurate details at your fingertips.
Because let's be honest, scaffolds are essential for so many jobs.
Oh, absolutely.
But they can also be a major safety hazard.
You got it.
Understanding these regulations is really the key to preventing those accidents
Exactly.
from happening in the first place.
Yep.
And today we're focusing on those essentials that every safety-minded individual should know.
Yeah, we're going to cover everything from weight limits and platform specifics to what you need to know about using different components and making sure that those supports are rock solid.
All right, let's jump right in. We're starting with 1926.451A.
Okay.
Which covers scaffold strength and capacity.
All right.
This one's foundational.
Uh-huh.
And it states that scaffolds have to be able to handle 4 times their intended load.
Right.
On top of their own weight.
Yes.
It seems like a pretty hefty requirement, right?
It is, and there's a really good reason for it.
Okay.
Think about it. You've got workers moving around, materials being shifted, maybe even some wind gusts, depending on the environment.
Right.
That 4X factor, it is a safety buffer, ensuring the scaffold can handle those real-world variables without buckling under pressure.
So it's not just about the static weight. It's about those unexpected forces that can pop up on a job site.
Exactly. And 1926.451A2 gets even more specific.
All right.
Focusing on connections to roofs and floors, this is where we see the importance of counterweights.
Okay.
Especially with adjustable suspension scaffolds.
Interesting.
These connections need to be able to resist 4 times that tipping moment.
What is tipping moment?
It's essentially how much force it would take to make the whole thing topple over.
Oh, okay, okay.
And depending on whether the scaffold's at its rated load or its stall load, the force those connections need to resist can be even higher.
Really?
Up to 1.5 times greater.
Wow, that's a lot of force.
It is.
It really makes you realize that scaffold stability is a whole system.
Yeah.
Not just about the platform itself.
You got it. Precisely.
And we see that theme continuing in sections 1926.451A3 and 4, which deal with suspension ropes.
All right.
These ropes are constantly under tension, supporting the entire weight of the scaffold and everything on it.
Yes.
That's why they have a higher load requirement.
Right.
6 times their intended load.
Makes sense, right.
It does. They're like the lifeline of a suspension scaffold.
Yeah. Yeah.
So what happens when those hoists that control the ropes reach their maximum load?
Good question.
Yeah.
1926.451A5 talks about stall load.
Okay.
Which is the maximum load a hoist can handle before it basically stops working.
Yeah.
OSHA mandates that the stall load can exceed 3 times the rated load.
Okay.
It's like a built-in safety mechanism.
So it's not just about having strong ropes.
No.
It's also about having reliable equipment that can handle those loads safely.
You got it.
And all of this emphasizes the importance of 1926.451A6.
Okay.
Which highlights the need for qualified design.
Yes.
You can't just slap a scaffold together with random parts.
You can't.
It needs to be designed by someone who understands the forces involved and can ensure it'll hold up under those stresses.
Absolutely.
It's like the difference between building a house of cards and a structurally sound building.
You got it.
There's a reason why architects and engineers exist.
Exactly. So let's move on to the platform itself.
Okay.
1926.451B1 gets into the specifics.
All right.
Starting with the requirement for fully planked platforms. This ensures workers have a solid, stable surface to stand on.
Okay.
But of course, there are exceptions to every rule.
There always are.
Right. Sometimes wider spacing between platform units is necessary.
Right.
But even then, the employer needs to demonstrate why that's needed. And there's still limits on how wide that spacing can be.
For our listeners out there who are responsible for scaffold safety, have you ever run into a situation where fully planked platforms just weren't feasible? How did you navigate those challenges while still ensuring worker safety?
It's a great question.
Yeah.
And one that emphasizes critical thinking in safety.
Absolutely.
You need to know the rules, but you also need to be able to adapt to real-world situations while staying true to those safety principles.
Right.
And speaking of adapting,
Yeah.
1926.451B1 makes an exception for walkways.
Okay.
And areas where the scaffold is being put up or taken down.
Right.
It wouldn't make sense to require full planking for areas that are only going to be used temporarily.
Yeah, that makes sense.
But even in those cases, employers still need to make sure there's enough planking to provide a safe working surface. So it's about being practical while still maintaining those safety standards.
Now, 1926.451B2 gets into platform widths.
Okay.
The general rule is that platforms and walkways need to be at least 18 inches wide.
All right.
Which seems reasonable.
Mm-hmm.
But I'm seeing there are exceptions here as well.
There are.
Okay, like what?
Some scaffolds, like ladder jack scaffolds or roof bracket scaffolds, a narrower width requirement of 12 inches.
Got it.
Due to their design.
I'm assuming those narrower widths wouldn't be ideal for every situation, though.
You're right.
Okay.
And that's where 1926.451B2 comes in.
Okay.
This exception is for those situations where you're working in a really tight space.
Right.
And you simply can't physically achieve that 18-inch width.
Like working between two buildings or in a narrow alleyway?
Yes, exactly.
What happens in those cases?
The regulation acknowledges those limitations.
Okay.
And says the platform needs to be as wide as feasible. But even more importantly, workers need to be protected by guardrails.
Okay.
Or personal fall arrest systems in those tight spaces.
Got it.
So it's about layering those safety measures when the ideal platform width just isn't possible.
Absolutely. Okay, so we've covered platform width, distance from the work phase. What's next?
Sections B4 and B5 deal with how far those platforms can extend past their supports.
Okay.
The longer the extension, the greater the risk of tipping.
Right.
So the regulations get more specific as that length increases.
It's like a seesaw.
Yeah.
The further out you go, the more likely you are to tip over.
Perfect analogy.
Right.
Yeah.
And sections B6 through B8 address how platforms that are abutted or overlapped need to be supported for maximum stability.
Yes.
We want to make sure everything is locked together securely and can handle the weight.
Exactly.
I'm noticing a trend here.
What's that?
A lot of these regulations are about preventing those tipping scenarios.
Yeah.
And making sure that those platforms are as stable as possible.
You're absolutely right.
And even something as seemingly simple as paint gets addressed in 1926.451B9, paint. Why would OSHA care about paint?
Because opaque finishes can hide cracks and other defects in the wood, making it harder to spot those weaknesses during inspections.
Okay.
It's about keeping those platforms visible.
Right.
So safety issues can be identified quickly.
So it's not about aesthetics.
No.
It's about functionality and safety.
Exactly.
Okay.
Now, let's talk about something that's probably on the mind of every safety professional.
Okay.
Mixing and matching scaffold components. Can you use parts from different manufacturers on the same scaffold?
I'm guessing the answer is a bit more nuanced than a simple yes or no.
You know it.
Okay.
1926.451B10 says it's okay to use components from different manufacturers.
Okay.
But with a big caveat.
What's that?
They have to be compatible and fit together seamlessly.
So no forcing parts together or trying to make something work that clearly doesn't fit.
Exactly.
Okay.
If you have to hammer something into place, that's a major red flag.
Got it.
And even if the parts do fit together, a competent person still needs to evaluate the entire assembly to ensure its structural integrity.
So it's not enough for the individual parts to be strong.
It's not.
They need to work together as a system.
They do.
It reminds me of some assembly required furniture kits.
Yeah.
Sometimes, even if you get all the parts together, it still doesn't feel quite right.
That's a great way to put it. And 1926.451B11 addresses another compatibility issue.
Okay.
Mixing different metals.
Okay. I'm curious about this one.
Yeah.
Why is mixing metals a concern?
Because of something called galvanic action.
Okay.
Basically, different metals can corrode when they're in contact with each other, especially in damp environments. This corrosion weakens the scaffold over time, making it more susceptible to failure.
So it's not just about the immediate fit.
No.
It's about long-term durability and preventing those hidden weaknesses from developing.
Exactly.
This is great information for anyone who's ever had to assemble a scaffold.
Absolutely.
Now that we've covered the basics, of scaffold strength, capacity, and platform essentials.
Right.
Let's move on to something that's literally the foundation of it all.
Okay.
The support.
The supports, yeah.
This is where things get really interesting.
They do.
After all, without proper support, the whole scaffold is useless, right?
You're exactly right.
So let's take a closer look at what OSHA has to say about making sure those scaffolds are supported correctly.
Okay, let's do it.
Perfect. We'll dive into that in the next part of our deep dive.
Sounds good. Welcome back, everyone. It's time to dig deeper into those OSHA scaffolding regulations.
Yes, specifically how we make sure those structures are standing strong and steady.
Exactly. We've talked about the platform itself, but now let's look at what's holding it up.
Yeah.
Because a solid foundation is key, whether you're building a skyscraper or setting up a scaffold.
Right.
Section 1926.451C of the OSHA standard focuses on supported scaffolds.
Right.
Those resting on a solid base rather than hanging.
Got it.
And one of the first things it addresses is that critical height to base ratio.
So how high a scaffold can be compared to how wide its base is.
Exactly. Yeah. I'm guessing that ratio plays a big role in stability.
It's got to, right.
You are spot on.
Okay.
That ratio is crucial for preventing those nightmare scenarios of a scaffold tipping over.
Right.
The taller the scaffold, the wider and more stable the base needs to be.
Okay.
OSHA sets that maximum ratio at 4.1. So if your scaffold is 16 feet high, that base needs to be at least 4 feet wide.
So it's kind of like building a tower out of blocks.
Yeah.
The wider the base, the less likely it is to topple over.
Exactly.
Simple as that.
And if you exceed that 4.1 ratio, say you need to go even higher with your scaffold.
Right.
Then you absolutely need restraints.
Okay.
Like guys, ties or braces.
Got it.
To keep it stable.
To keep it from tipping over.
Exactly. These restraints provide extra support and prevent that swaying motion that can lead to a collapse.
So it's not just about the base itself.
No.
It's about those additional support systems for taller scaffolds. Right. And where do these restraints need to be placed for maximum effectiveness?
That's where 1926.451C gets into the nitty-gritty.
Okay.
Those restraints need to be strategically placed to prevent swaying or tipping. They should be installed close to that 4.1 height mark and then repeated vertically at specific intervals.
Got it.
OSHA provides detailed guidelines on these placements, ensuring those forces are distributed evenly and the scaffold remains stable.
So there's a real science to it.
There is.
It's not just about slapping on a few extra supports randomly.
Right. And 1926.451C13 brings up another factor that can affect stability.
What's that?
Eccentric loads.
Eccentric loads? What are those exactly?
Think of it as any weight that's off-center or unevenly distributed on the platform.
Okay.
Imagine a pile of heavy bricks stacked on one side of the scaffold.
Okay, I get it.
That uneven weight distribution can put a lot of stress on a specific point, increasing the risk of tipping, especially if the scaffold isn't properly restrained.
So it's about more than just the total weight on the platform.
Yes.
It's about how that weight is distributed.
Exactly.
Okay, that makes sense.
And then we have 1926.451C2, which focuses on the foundation itself.
Right.
It might seem obvious. Scaffolds need a good foundation.
Of course.
But OSHA gets into the specifics of what constitutes an acceptable base.
What kind of things would not be considered a good foundation?
Yeah.
I'm guessing a pile of loose dirt wouldn't cut it.
You're right.
Okay.
The regulation calls out a whole list of unacceptable foundations.
Okay.
Unstable objects, loose bricks, anything that could shift or settle under the weight of the scaffold.
Right.
You want a solid level surface that can handle that load without any movement.
I'm seeing that OSHA even specifically mentions forklifts in 1926.451C2V.
Yes.
I can see how a forklift could be useful for supporting a scaffold platform.
Yeah.
But I'm guessing there are some strict rules about doing that safely.
Absolutely.
What are those?
If you're using a forklift to support a scaffold platform, the entire platform has to be attached to the fork.
Okay.
And you can't move the forklift horizontally while anyone is on that platform.
So no driving around with workers perched precariously on a forklift-supported scaffold. That seems like a recipe for disaster.
You're telling me.
Okay.
And to wrap up our discussion on supported scaffolds, 1926.451C emphasizes that those supports need to be plumb, meaning perfectly vertical, and properly braced to prevent any swaying or shifting.
Plumbness is one of those things that seems straightforward. But I bet it's trickier to achieve in practice than it sounds.
It can be.
What are some of the challenges in making sure those supports are perfectly vertical?
It can definitely be challenging, especially on uneven ground or when working with multiple scaffold sections.
Okay.
But it's crucial because even a slight lean in those supports can compromise the stability of the entire structure.
Yeah. Okay.
It's like that Leaning Tower of Pisa. It might be a famous landmark, but you wouldn't want your scaffold looking like that.
That's a great visual.
Okay, so we've covered the essentials of supported scaffolds, making sure those platforms are resting on a solid and stable base.
Right.
But what about those scaffolds that aren't supported from below?
Exactly.
What about those that are suspended from above?
Those are the interesting ones, right?
Ah, yes. Suspension scaffolds. Those hanging high in the air, often used for high-rise work and those hard-to-reach places, since they're not resting on the ground. The regulations around those are even more stringent, focusing heavily on those support devices that hold the whole thing up.
It makes sense.
Makes sense.
Let's dive into those regulations and see what OSHA has to say about keeping those suspended scaffolds safe and secure.
Absolutely. This is where things get really interesting, so let's take a closer look. And we're back
with the final part of our deep dive
into OSHA's scaffolding regulations.
It's time to talk about those scaffolds that aren't standing on solid ground.
Right.
Suspension scaffolds.
Yes, those platforms.
Hanging high in the air.
Often seen on skyscrapers or bridges.
Right, since they're not supported from below.
Right.
The safety requirements shift to those all-important suspension components.
That's right.
Makes sense.
So where do we begin with ensuring that those suspended scaffolds are safe and secure?
What does OSHA have to say about this?
Well, 1926.451D is our go-to section for all things suspension scaffolds.
Right.
It starts by emphasizing that whatever's holding up those support devices, whether it's outrigger beams, cornice hooks, or parapet clamps, needs to be able to handle at least 4 times the load imposed by the scaffold itself.
Okay, so it's the same safety margin principle we've seen before.
Yes.
But applied to the supporting structure itself.
Exactly.
We're making sure the foundation of the suspension system is rock solid.
Exactly. And just like with those direct connections we discussed earlier, the strength requirement increases depending on whether the scaffold is operating at its rated load or its stall load.
So knowing those load limits and how they impact the entire support system is crucial for anyone working with suspension scaffolds.
Absolutely.
Okay.
Now let's focus on those outrigger beams, those long arms extending from the building to support the suspension ropes. 1926.451D2 lays out the requirements. They need to be made of sturdy material.
Like what?
Like structural metal. And properly restrained to prevent any movement.
So we're talking about heavy-duty beams that are securely anchored in place.
Yes.
Creating that stable base for the suspension system.
Right. And 1926.451D gets even more specific about how those outrigger beams need to be stabilized.
Okay, how so?
The most secure option is bolting them directly to the floor or roof deck.
That sounds like the most straightforward and reliable way to go.
It often is. But there are other methods like using counterweights, which can be effective when direct bolting isn't feasible.
Those mysterious counterweights again.
Yeah.
I'm starting to see how they play a crucial role in scaffold stability.
They do.
Even when the scaffold is suspended.
But it's important to note that not all suspension scaffolds can use counterweights. For example, Mason's multi-point adjustable suspension scaffolds are designed differently. And using counterweights with those could actually create instability.
So it's not a one-size-fits-all approach with counterweights? It's about understanding the specific design of the scaffold?
Yes.
And what stabilization methods are appropriate?
Exactly. And for those direct connections, 1926.451D3 requires a competent person to evaluate them and ensure they can handle the load for Mason's multi-point scaffolds. Those connections need to be designed by a qualified engineer with specific experience in that type of scaffolding.
So there's a real emphasis on expertise and making sure those connections are designed and evaluated by people who know what they're doing.
Absolutely.
And speaking of expertise, let's talk about those counterweights. 1926.451D3 has a whole section dedicated to them.
Yes.
And it's full of important details. First of all, you can't just use any heavy object as a counterweight.
Right.
So no piling up old tires or random junk as a counterweight.
Nope. The regulation specifically prohibits using flowable materials like sand or gravel.
Okay.
Because they can shift or spill,
right,
suddenly changing the balance of the scaffold.
Okay, got it.
Those counterweights need to be made of solid, non-flowable materials that won't change shape or position unexpectedly.
So they need to be securely attached as well.
You got it. 1926.451D3 mandates that counterweights be mechanically fastened to those outrigger beams, preventing any accidental movement.
So we've got our outrigger beams stabilized,
right,
either with bolts or those carefully chosen and secured counterweights. But what about those tiebacks mentioned in 1926.451D3?
Yes.
What's their role in all of this?
Tiebacks are like those extra safety lines that anchor the outrigger beams to the building, providing an added layer of security.
So they're like the safety chains you'd use on a trailer to prevent it from detaching from your vehicle.
Exactly.
That extra layer of security.
They're especially important for beams that aren't directly bolted down.
Right, okay.
And those tiebacks need to be just as strong as the suspension ropes themselves. 1926.451D37 makes that very clear.
So they're part of the support system.
Yes.
So they need to be able to handle the same forces.
Exactly.
It's all about redundancy and ensuring there are multiple layers of support.
Yes.
To prevent that catastrophic failure.
Right.
And there are specific rules about how those tiebacks are attached. Yes. They need to be secured to a structurally sound part of the building, not to flimsy handrails or loose bricks.
Exactly.
So no cutting corners when it comes to those attachment points.
No.
Everything needs to be solid and reliable.
Absolutely.
And something else we see emphasized throughout 1926.451D3 is that those outrigger beams and tiebacks need to be installed at a right angle to the face of the building.
Yes.
Unless there's an obstruction.
Correct.
Why is that right angle so important?
It creates the most stable configuration. When forces are applied perpendicularly, they're distributed more evenly, reducing the risk of those beams bending or buckling under pressure.
So it's about maximizing that stability.
Yeah.
And ensuring the forces are being directed in the most structurally sound way.
Precisely.
Okay.
And we see those same principles applied to other types of support devices.
Okay.
Like cornice hooks and parapet clamps. They all need to be securely fastened, often with those same tieback requirements to prevent any movement or detachment.
So whether we're talking about outrigger beams, cornice hooks, or parapet clamps,
yes,
the focus is on creating a rock-solid foundation for that suspension system.
Exactly.
And now let's move on to the ropes themselves.
Okay.
Section 1926.451, take D, has a lot to say about those.
It does.
Starting with the amount of rope that needs to be wound around that hoist drum. Why is that amount of rope so important?
It's all about ensuring there's enough rope to safely lower the scaffold.
Right.
If you run out of rope before the platform reaches the ground, you've got a major problem.
You're in trouble.
A potential free fall.
It's like making sure you have enough thread on a spool to finish sewing a button. You'd want to run out halfway through and have everything unravel.
Perfect analogy.
Okay.
And 1926.451D7 throws out a big NO to using repaired wire rope as a suspension rope.
Now, why is that?
I'm guessing that's because even a well-repaired rope might not be as strong as a new one, especially when you're talking about supporting an entire scaffold.
Makes sense.
Those suspension ropes are under constant tension.
Yeah.
And any witness could have disastrous consequences.
Right.
And the regulations get very specific about how those ropes are connected with detailed requirements for splicing, thimbles, shackles, and even the type of clips used.
Okay.
Again, it's all about maximizing the strength of those connections.
So no weak links in the chain, so to speak.
Right.
And then there's 1926.451D10, which focuses on rope inspections.
Yes.
A competent person needs to check those ropes for any defects before each shift and after any event that could have damaged them.
Right.
We're talking about looking for physical damage, broken wires, corrosion, heat damage, anything that could compromise the integrity of the rope.
So those inspections are a critical part of preventing rope failure.
They are?
Are there any specific situations that would warrant an immediate rope replacement?
Yes.
Even if it doesn't appear visibly damaged?
Absolutely.
Like what?
The regulations mention those secondary brakes built into some hoists to prevent overspeed.
Okay.
If that brake has been activated, it means the rope has been subjected to extreme force and needs to be replaced.
Wow.
Even if it doesn't show obvious signs of damage.
Okay.
It's like a safety valve that tells you that rope has been pushed to its limit and can't be trusted anymore.
Wow, that's a great safety feature. It is.
So it's not just about visual inspections.
Yeah.
It's about understanding those hidden stresses that can weaken a rope over time.
Exactly.
And since we're talking about hoists, 1926.451D has a whole section dedicated to them as well.
It does.
Covering everything from testing and power sources to braking systems and emergency stops.
Yeah.
It makes sense.
It does.
After all, that hoist is what's controlling the movement of the entire scaffold.
Right.
So it needs to be in tip-top shape.
Yes.
Are there any specific types of hoists that OSHA prohibits for use on suspension scaffolds?
1926.451D14 specifically bans gasoline-powered equipment and hoists from being used on suspension scaffolds.
I'm guessing that's because of the risk of carbon monoxide poisoning.
Yeah.
Especially when working high up where ventilation might be limited.
Exactly.
Makes sense.
Safety isn't just about the mechanical aspects of the equipment. It's about considering those environmental hazards as well.
Well, we've covered a lot of ground in this deep dive.
We have.
Into OSHA's scaffolding regulations.
A lot of info.
We've explored everything from scaffold strength and platform essentials to those critical support systems, the importance of worker training, and even the specific requirements for those suspended and mobile scaffolds.
It's been quite a journey through the world of scaffold safety.
Absolutely.
Hopefully our listeners now have a much deeper understanding of these regulations and how they work together to create a safer work environment.
And it's important to remember that these regulations aren't just about following rules blindly.
Right.
They're about understanding the why behind those rules.
Yes.
And applying critical thinking to every situation.
Well said.
Because at the end of the day, it's all about keeping workers safe.
Absolutely.
And ensuring everyone goes home at the end of the day injury-free.
That's it.
A huge thank you to Safety One Source for sponsoring this deep dive into scaffold safety.
Yes, thank you.
Be sure to visit their website for more information and those valuable resources on creating a safer workplace.
And to all our listeners out there, thanks for joining us.
Thanks for listening, everyone.
Remember, knowledge is your most powerful tool when it comes to safety.
It really is.
Stay informed, stay vigilant, and stay safe.
And that's a wrap on another insightful episode of The Deep Dive.